Hello, my name is Courtney Mushbacher. I am a Bachelor of Science in Agriculture major at Murray State University here in Murray, Kentucky. Today I'm going to be talking to you about the 12 soil orders of soil taxonomy. I'll be giving you the name of each, a picture of each, and some characteristics to go along with each soil order. Our first soil order is histosoils. Histosoils is considered the organic soil order. Every soil order has multiple suborders, but usually there's a common one. The common suborder for histosoils is hemist. In some countries, histosoils is used for fuel. The word histos is Greek for tissue. Histosoils have 0 to 60% clay, along with a high water and nutrient holding capacity. They also have a low bulk density, as you can see in the picture. They are a saturated part of the year, have a deep O horizon, and they account for 1.2% of the global soil orders and 1.3% of the U.S. soil orders. These percentages do not include areas that are ice only. Next, we will move into our old soil orders. Our first one being alpha soils. Alpha soils is actually considered mature. The common suborder of alpha soil is boralf. This soil order can be found in deciduous forest soils. It is also found here in western Kentucky. Alph in alpha soils has an Al, which stands for aluminum, and the F, which actually is short for Fe, which stands for iron on the elements chart. This soil order has a well-developed A, E, B, and C horizon. It has greater than 35% base saturation, also in the BT horizon. This accounts for 9.6% of the global soil orders and 14.5% in the U.S. Our next old soil is mollisols. Mollisoil is also considered one of the mature soil orders. Its common suborder is Udall. It is under grasslands, also in the prairies. This is considered the gold soil for farming. Mollins, which is where mollisols comes from, is Latin for the word soft. Mollisols have mollic epipedon, which is a fertile surface horizon, which would be the top. This is found in subhumid to semi-arid climate or areas that go from cold to hot. It's very fertile and productive and is the most prized soil, hence why it's called the gold soil for farming. Mollisols also have a defining factor. These white spots in the soil are calcium spots called caliche. Mollisols account for 6.9% global and 22.4% of the U.S. soil orders. Our next old soil is eudosols. Eudosols, as I said, is an old soil order. Its common suborder is Xelrut. It is also a forest soil found in tropical areas. Eult is from the word ultimus, which is Latin and means last ultimate. This has well-developed horizonization, which means you can clearly tell the differences between each horizon when looking at the profile. It is acidic and has less than 35% base saturation. If managed well, it can be very productive. It is high in 1-to-1 clays like kaolinite. Eudosols can account for 8.5% global and 9.6% of U.S. Another old soil order is spodosoils. Spodosoils have a common suborder of aquad. They are also a forest soil. Spodos is Greek for wood or ash. It has a high sand content, it's very acidic, and has a low percent base saturation. It's also very infertile. It's highly leached, which means that it has a loss of the water-soluble plant nutrients. It does have an O horizon, but it has no A horizon. It accounts for 2.6% global and 3.3% of U.S. Our last old soil order is oxasols, which is actually the oldest soil order. Its common suborder is Torox. It's developed in weathered areas or tropical areas as well. Ox is from the French word oxide. It is highly weathered and has low activity clay. It has iron, which is Fe, and aluminum, which is Al, oxides in it. It has a very low percent base saturation as well. It accounts for 7.6% global and less than 0.01% in the U.S. We next move on to the young soil orders, our first being entosols. The common suborder for entosols is fluent. It has little to no profile development, as can clearly be seen in this picture, and it has weakly developed mineral soils. It accounts for 16.3% of global and 12.2% of the U.S. Our next young soil order is Inceptosols. Inceptosols' common suborder is Orchrept. It has few diagnostic features, and depending on the development, it sometimes has a Fragipan horizon. Epipedon is usually ochric, but sometimes it can be malic or umbric. This accounts for 9.9% global and 9.1% of the U.S. Our next young soil order is Andesols. Andesol's suborder, common one, is Vitrand. It's found in volcanic areas which have ash. It's also in the tropical areas. It has a sufficiently thick layer of the ash as well. This volcanic ash produces amorphous, which is poorly crystallized silicate materials. The combination of ash mineral and the organic matter makes this soil order have light and fluffy soil. It's easily tilled, but rainfall keeps it from being deteriorated and ruined due to wind erosion. It also has a high natural fertility. This accounts for 0.7% of global and 1.7% of the U.S. Our next young soil order is Gellosols. Gellosols' common suborder is Turbelle. It is in cold and wet climates. It has a permafrost layer. Permafrost is a layer of material that keeps below 2 degrees Celsius for more than 2 consecutive years. The issue with this is when it melts, it can cause the soil to lose bearing strength, which eventually causes it to collapse. This is a big problem in areas like Alaska, where roads can collapse because the soil decides to melt. This accounts for 8.6% global and 7.5% of the U.S. Our next young soil is Aridosols. This again is a young soil order with a common suborder of Argid. It has a hot and dry climate. It also forms petrocalcic horizons, which means it's difficult to build on. It has desert pavement as well. Erosion removes the fine particles from the surface, and it leaves behind wind-ratted pebbles, which is what desert pavement is. As you can see in this picture, you can see some rocky areas. This is a very hard soil to build on, and when you do build, it causes much more money to be spent into the area for excavation of the soil. This accounts for 12.7% global and 8.8% of the U.S. Our last soil order, the 12th soil order, which is also a young soil, is Vertisols. Its common suborder is a quert. This soil is known for its shrinking and swelling clay. It is not smooth. Verto is Latin for turn. And able to be classified as vertisoil, it must have more than 30% expanding clay. It has high expansion and contraction, and it self-mixes as well. It has poor horizonization, except it does have a deep A horizon. Poor horizonization means that you can't very clearly tell the difference between each soil horizon when looking at the profile. It also has gilgite topography, which means that it forms small lake forms in the expanding clay soil. The next thing is it is difficult to manage. This accounts for 2.4% of global and 1.7% of the U.S. And that is the 12 soil orders of soil taxonomy. Thank you for coming.